Hello. Today we are looking at a problem where we are to decide if the data that we have could be modeled by a linear function or not. So we have data for income taxes over here, and we're to use X for the taxable income, so this is my X column. We're to use Y for the tax, so this is my Y column. The first thing that we're asked to do is to complete the table of differences, and that table is down here at the bottom of my screen. So the change in X is already filled in for me, and we can see that these numbers match with the data that we have in the table. So the income is going from 67,500 to 67,600, etc., 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 and we're to figure out the change in the Y values for those incomes. So let me grab my pen. All right, so for this first block in our column, we are going to see how much the Y value has changed from here to here. So I'm going to take on my calculator, and let me see if I can go up here where I have some space. I would take 9306 and I would subtract 9291. So when I do that on the calculator, I end up with a value of 15. And so that's that first block. So now I'm supposed to do the next one. So right here, this is a change of 15. So between these two, and when we do this, we're always taking our Y2 minus our Y1. So my next calculation here is 9321, subtracting out 9306. And we get an answer of 15. And then we do the next one because we have 4 of these, so this grouping. So we have 9336, subtracting from that 9321. And again, we get value of 15. And so this is looking very promising as we see all of these matching. That has some meaning to us. So we do this last pair. And so we have 9351. And we subtract 9336. And once again, we get 15. So can this data be modeled by a linear function? The answer is yes. And the reason why is because it has a constant rate of change. In order to see a constant rate of change, we have to see that as the X changes, and here the X changes by $100 each time, that the Y changes by a constant amount as well. So we see that every single time when we subtracted, the Y changed by $15. So it says if it can, which we decided yes it can, find the linear model. So we know that a linear model is a Y equals mx plus b model. And we need to replace both the m and the b with actual numbers. So m, the slope, describes the rate of change, and we know that m is equal to the change in y divided by the change in x. So we have already calculated the change in y is 15, and that happens when x changed. So from 67,500 to 67,600, x changed there by 100. If I divide this out on my calculator, 0.15. And so I have a slope value, so I can go over here to my equation. I now know y equals 0.15x plus b. So in order to figure out a value for b, I need to plug in numbers for x and y, and I can truly use any ordered pair from off of this original table of data. So I'm going to use the first one, and it said x was the income, so that's what I'm going to fill in for the x values. So 0.15 times 67,500. And plus b, that's what I'm solving for. And my y value there was 9291. So then I have to do the math. So And I'm using a calculator here, which I'm not showing on screen, but you can take this 0.15 times the 67,500, and that gives me a value of 10,125 plus b. And then I'll subtract this amount from both sides of my equation. These guys cancel out, and so that gives me b equals. And over here I have, again, using a calculator, this 9,000 number minus this 10,000 number, a negative 834. So now I have all the information that I need for a linear model. So my linear model, y equals, instead of m, I put in the slope of 0.15, x, and instead of the b, I put in this value that we calculated, so minus 834. And so when we are looking for data, for it to be perfectly linear, we have to have an exactly constant rate of change. And so that rate of change is found through our slope formula, subtracting. Truly, to figure out the change in y, we did this y2 minus y1, which we recognize as being part of slope formula. And then to find the actual slope, where we got this 100, was from doing the x2 minus x1. And so really within this table, we were working with the slope formula. So seeing these constants allowed us to conclude that it would be linear and allowed us to find the actual slope for this data.